Namaskar, my dear friend. Myself DP Gangwar. I once again welcome you in my YouTube channel, DP Forensic Lab. In today's video, I am going to discuss two very important terms used in digitization of the audio recording. That two very important terms are sampling rate and the bit depth. So, whenever you're talking about the audio expert, we have to thoroughly knowledge about the physics of the audio signal. So, whenever we are going to discuss about the digitization of the audio signal, these two terms are very important: sampling rate and the bit depth. So, what is the audio signal? Audio signal is a continuous wave-like signal, like this continuous signal that directly represent the sound pressure. But in the digital audio signal, it's a series of the discrete numerical values like this. This may be your signal may be 0 or 1, 0 or 1, 0 or 1. So this is represented by the 0 or 1 that approximate of the original signal. So now what is the difference between the analog and the digital signal? What is a analog signal? This is a continuous. It is a continuous, smooth waveform, analog signal. What in digital audio signal convert the analog waveform into a series of the discrete numerical values, various numerical values 0, 1, 0, 1. That process is called a sampling and the quantization. And whenever when we talk about the storage, for the storing the analog signal, it is a physical media like a vinyl records or the magnetic tape. It is a physical media. What in the digital audio, ye store in the binary code 0, 1 or the digital device like a computer and the CD can be used to store the digital audio signal. What is the features of both analog or the digital audio? What is the advantage or the disadvantage of the audio, analog and the digital signal? In analog audio, what is the advantage? It is a more natural due to the continuous wave. It is a more natural. What is the disadvantage? Prone to noise, degradation. Degradation occurred in the analog signal. With each copy of the playback, when we are playing the again and again and again, the quality or news introduce itself in the signal. So this is a main the disadvantage, and also the limited editing capability. There is some limitation about the in editing. But in the digital audio, what is the advantage? Because this stores in the digital form 0 and 1. It allow endless perfect copies. You can make 100 copies through 300 copy or how many copies. No quality change. But in the analog signal, we are making the copy to copy to copy to copy. The quality degrade. What in the digital, the quality of, due to the copy, quality don't affect. It is a main advantage. And what is a disadvantage? It can artifact like a quantization noise. Quantization noise may be occur when we digitize this audio signal to the digital signal, especially if the bit depth is low. We can reduce the noise quantized noise by increasing the bit depth. So this is a feature of the analog audio or the digital audio. Now, there are two important term. One is a sampling. What is a sampling? How fast we do have the sample of the analog signal? How fast we record the sample? The number of the sample taken, this is called the sampling number, or we can say sampling rate. And this is governed by the Nyquist theorem. When we are talking about the digitization, very important theorem involved in this process, this is Nyquist theorem. Please read about the Nyquist theorem. And what state the Nyquist theorem? It's a mathematical that give us the guidelines for digitization. It stated the sampling frequency should be twice of the frequency of the wave which are going to digitize. Suppose if the our frequency of a signal is equal to 20 hertz, suppose this is a frequency of a signal, audio signal. So sampling frequency as per Nyquist theorem, this should be more than of the 20, suppose got 20k. So sampling frequency should be more than 20k, more than the 40k hertz. This is a Nyquist theorem. Now you can understand the better way digitization of the audio signal. This is a analog signal, continuous smooth wave, and the sampled at the of the original signal twice of the frequency. In this case, just 2 times. So this is a reconstruction. So at least as per the Nyquist theorem, at least the sample frequency should be twice to reconstruct the wave. Otherwise, if you sampled less than of the 2 of the actual signal, you cannot reconstruct of the audio signal after digitization. If the sample frequency is more than 2, then you can get the better output. This is output, digital signal. So I have talked about if the 20 hertz is taken as a largest frequency that a human can hear, so sample Nyquist theorem should be more than the 44k. This is a Nyquist theorem. Now another term is a quantization. When the sample is taken, the voltage amplitude of a signal at a moment at time is rounded to the nearest allowed voltage level, which is represented by a unique binary number. And this binary number is called the bit depth n. This determines the precision with which you can represent the sample amplitude, and this can be written as 2 to the power n. Bit depth, this is a depth. How depth? If depth is more, there is a better quality or precision is a better. We will discuss the later what is a bit of the bit effect, like this. The difference between the original sample voltage and the quantization sample voltage that occur a rounded figure is called the quantization error. There is always error when we are the quantization. Suppose this is a analog. This wave. and the quantization is like this. This is a quantization. So you can record the signal at this or this, because this is a limit. This is a limit. So this is a delta. So this delta is a quantization error. This occur, or this error can be increased with the increasing of a resolution of the quantization or number of the bits. If the B are increasing the number of bits, suppose 16 bits, 16 bit, 16 bit has less noise compared to the 18 bit. 18 bit. 16 bit has the less quantization noise with respect to the 8 bit. So this is a difference between the, yeah. You can better understand by this graph also. Sampling rate, higher sampling rate is higher bit depth. Here, increasing the bit depth. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, suppose go 16, and is a more bit depth. So higher bit depth, less error. Further higher depth, very less error or the no error. So generally two bits are used, 16 bit, often used for the final distribution, and 24 bit generally referred during the recording and the reproduction of the signal. So these are two very important terms whenever talking of the digitization of the audio signal: sampling frequency, sampling rate, or the bit depth. If you, my dear friend, you would think it is a slightly informative, please subscribe my channel DP Forensic Lab or give any comment. Thank you.